Hi everyone, this is Yan. In our previous presentation, we discussed frequency distribution, which summarizes data and describes which scores occur most often in a dataset. In this presentation, we'll use three measures of central tendency to summarize data and to describe samples and populations. Central tendency is the statistical measure used to determine the center of a distribution of data and find the single score that's most representative or descriptive of the dataset. This is a dataset of 10 numbers. The mean is the average of the sum of all the scores. The median, after you put the data in numerical order, the median is the midpoint of this data set. There are two scores, 2 and 3 in this data set, so the median is the average of 2 and 3, which is 2.5. After you put the data in numerical order, the mode is that score that occurs most often in the data set. The way to compute the mean is to sum up a set of scores in the dataset and divide the sum by the total number of scores. The mean is the most commonly reported measure in published articles. Population mean is identified by mu. The symbol sigma means sum of, and lowercase italicized x represents each score in the dataset. The uppercase N represents the population size. Sample mean is identified by uppercase italicized M. Sometimes it's also represented by X bar. And lowercase italicized n represents the sample size. So now, can you quickly compute the mean of this data set? The answer is 7. So we sum up all the numbers in this data set of 8 and divide the sum 56 by 8. So the mean is 7. Sometimes we have a few groups of samples and the sample sizes are different. They are unequal or disproportionate. That's when we use the weighted mean. To compute the weighted mean, we add up each group's sum. That's the weighted sum. Then we add up the numbers of scores in each group, and that's the combined n. We divide the weighted sum by the combined n to get the weighted mean. In this example, there are 3 sample groups: the lean group, the overweight group, and the obese group. To compute the arithmetic mean, we use the 3 group means, 46 plus 58 plus 73, and divide them by 3. The mean is 59, which is closer to the overweight group's mean. But if we look at the sample size, the obese group has 30 subjects, and its sample size is larger than that of the other 2 groups combined. This is when we need the weighted mean. To compute the weighted mean, the first step is to get the sum of each group. 46 times 12, 58 times 14, 73 times 30, and then we sum them up. And that's the weighted sum. And the next step is we sum up the numbers of scores in each group. 12 plus 14 plus 30, and the combined n is 56. So the weighted mean is 63.5. And it shifts towards the larger group among the 3 samples. Another way to use weighted mean is how we usually calculate a final grades. So in the example, there are 3 types of assignments for this class: exam, quiz, and a project. And the weight towards the final grade of each assignment are 60%, 20%, and 20%. So student A got 70 points for the exam, 98 points for the quiz, and 100 points for the project. Now we treat the weight, the percentage of the weight, the same as the sample sizes. Now, if you pause the presentation, do you think you can compute this student's final grade? Take your time. When you resume the presentation, we can compare numbers. The arithmetic mean here is just shown to compare with the weighted mean. So it's not necessary, it's not required. So the first step, we need to get the sum of each group. And 60% is 0.6. So 70 times 0.6, 98 times 0.2, 100 times 0.2. And then we add them all up and get the weighted sum is 81.6. The next step is to add up all the percentages. When we combine the percentages, it's 100%, which is the same as 1. So the weighted mean is 81.6. Did you get it right? Every score in a distribution affects the mean. In this data set of 10 scores, the mean is 5. If we increase the score 1 to 6, the mean will increase. The mean is 5.5. It's larger than the original 5. If we decrease the score 9 to 4, the mean will decrease. It's 4.5 now. So when we change an existing score without changing the sample size, the mean will change. Another characteristic of mean is if we add a score or remove a score, the mean will change, unless this score is the same as the mean, the original mean. So this is the original set. The mean is 5. If we add 2, 2 is smaller than the original mean. The new mean is smaller than the original one, so 4.7. If we add a score 8, 8 is larger than the original mean 5, so our new mean will increase. The new mean is 5.3. If we remove a score 1, which is smaller than the original mean 5, our new mean will increase. It's 5.4. If we remove a score 9, which is larger than the original mean 5, our new mean is smaller now, 4.6. But if we add a score 5, which is the same as the original mean, the new mean is the same. If we remove a score 5, which is the same as the original mean, the mean will stay the same. The third characteristic of the mean is that if we add, remove, multiply, or divide each score by a constant, the mean will change by the constant. Here's the example. We have a data set A, B, and C, and the mean is A plus B plus C divided by 3, and the constant will be 5. We have a sample size of 3. So if we add or remove the constant 5 from each score, the new mean will be the original mean plus or minus 5. If we multiply each score by 5, the new mean will be the original mean multiplied by 5. If we divide each score by the constant of 5, the new mean will be the original mean divided by the constant of 5. The next characteristic of the mean is the sum of the differences of scores from their mean is 0. We'll use the same example from the previous slide. So the differences of scores from their mean is A minus mean, B minus mean, and C minus mean. The sum of the differences is we sum them all up, and that's the sum of the differences of scores from their mean. If you want, pause the video and finish the computation. See if you get the number 0 at the end. I hope you got it right. So the last characteristic of the mean is the sum of the squared differences of scores from their mean is minimal. We use the same example. If we want to know how far the scores deviate from their mean, we use the difference of each score from their mean. And then we sum them up. But then from previous slide, we just learned the sum of the differences is 0, which means there is no differences. The scores are not deviating from their mean, which is certainly not true. So to avoid getting this 0, we use sum of squares. We square each difference and then sum them up. So it's called sum of squares. Here is the example from our textbook with the real numbers plugged in. You probably say, 54 is definitely not minimal. Well, in next chapter, we'll use sum of squares to introduce the concept standard deviation. So we're not done yet. We'll use 54 and divide it by the sample size, which is 5. So 54 divided by 5, it will be 10.8. And then we'll square root 10.8. We'll get 3.2. So the number 3.2 is the standard deviation. So the median is the midpoint in a distribution. If you list a set of scores in numeric order, the median is the middle one. So the median position is the sample size plus 1 and divided by 2. We have this data set of 5 numbers, 5 scores. And the median position is 5 plus 1 and divided by 2, which is 3. So can you find which number is the median? So 1, 2, 3. So 44 is the median for this data set. Now another example. If we move number 8 from the data set, we'll have a sample size of 4. We are left with the 4 scores. So the median position will be 4 plus 1 divided by 2, and it's a 2.5. So 2.5 is between 66 and 44. It's between the second and the third position. So what do you think the median is? Yeah, the median is the average of 66 and 44, which is 55. the mode reflects the score or scores that occur most often in a distribution. So let's find the mode in this data set. I already put them in numeric order. And in last week, we used a simple frequency distribution table. So we can put all the numbers into this table. And X represents each score. And F is the frequency of each score. And we see that number 4 has occurred 8 times. So 4 is the mode of this data set. Now let's do some exercise. When 2 scores, they occur the same most frequency, and we call it a bimodal. And in this data set, what is the mode? The mode is 19 and 50. So the mode are 19 and 50 because they both occurred 3 times. When 2 scores occur with great frequencies, we call one as the major mode and the other one is the minor mode. So in this data set, which one is the major mode? Yeah, 19 is the major mode because it occurs 4 times. And 50 is the minor mode because it occurs 3 times. When there are several equally high frequencies, we call it no mode, like in this data set. They all occur 3 times. We usually report mean in a normal distribution. A normal distribution is a theoretical distribution in which the mean, the median, and the mode all fall at the 50th percentile or the center of the distribution. And the scores are symmetrically distributed above and below the mean. Mean is used for interval and ratio scale data because data on these scales can meaningfully convey information regarding differences between scores and their mean. We like to report mean because it includes all scores in its calculation. We usually report median in a skewed distribution of data. Skewed distribution occurs when a data set includes a score or a group of scores that fall substantially above the mean, that's positively skewed, or below the mean, that's negatively skewed. We use median because median is not influenced by outliers. Ordinal data convey direction only, not distance, because the distance of ordinal scale data from their mean is not meaningful. The median is used to describe ordinal data. That's why we use median to describe ordinal data. Mode is reported for modal distributions of data. Unimodal, 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 or bimodal, or multimodal. Nominal scale data represents something or someone. It is not quantity, so we use mode to describe it. And the key phrases in the description are usually most often, typical, or common. Thank you for listening. Please let me know your questions and feedback.